All right, the recording is in progress, hopefully for everyone. Uh, yeah, Vinesh. He's extremely excited to learn about YAML. Uh, he's just asking me where the mouse is. Really, I've not put the mouse here, so he's just asking me where the mouse is. The cat. So I am extremely excited to learn the behind the scenes of you know the YAML for KubeSlice, and I'm kind of stoked about this session personally because although I have kind of worked with this project for not really long, but significantly longer. Um, I think I'm I'm excited to see how it exactly is formulated behind the scenes. So, without further ado, I think I'll hand it over to Prasad, who is by now a very prominent face on all of our office hours episodes. And yeah, I think we shall just get started then. Over to you, Prasad.
Thank you, Divya.
Hey, hey,
Divya,
Prasad.
hey,
Yeah,
Supriya.
Hey, hi. Sorry to interrupt you and bother you. I just have one question,
yeah,
and I would need some direction around it.
yeah.
So I used to work in DevOps and Kubernetes. For I have worked for almost 1.5 year
Right.
in my previous firm.
Yeah.
But the profile that I'm presently working right now is nowhere linked to Kubernetes,
Hmm.
and I don't no longer have access to any such environment where I can, work and explore things and all that stuff.
Right.
So, how do you think, I can, because Kubernetes is something when I found a new passion in it, and I would definitely love to pursue this as a, interest of mine, and definitely in future, if I get any opportunities in market, I like to
Right.
pursue those opportunities. So, what do you think should be my approach, to get this cracking and going?
Yeah, that's a very good question, Supriya, because I personally
Hey,
was faced
hey,
with the
yeah,
same question back
I do.
in.
By the way, I did meet you in the recent Google Meet. You might not be knowing me, my person, but I did meet you over this. You were there in the meet, right, as a key speaker. So I think
I don't
you,
remember. I'm sorry.
yeah. So I've seen your session there, right?
So,
Anyways,
so Divya is a celebrity.
Hey,
Like,
I am
like
yeah.
not a celebrity. I
so,
am virtually.
it's like I know Modi, but Modi doesn't know me. That's a different problem.
It's not that I'm very bad with faces and names, and in general, that I love talking. The only thing I'm good at is talking to people. I'm very bad with names generally and faces, so I have to like meet you at least 2 3 times before I actually register your name. So it happens to a lot of people. So please don't take it
No
personally.
problem, no
I
problem.
am I am very bad at names and people, and I think this is like the best public forum. Arpit, now this is putting me on the spot. Please don't ask
What about me, Divya? Do you know me?
me. Yeah, I think I might have to take my amnesia pills because I don't remember anyone now. But no, the thing is, it's just I meet a lot of people, so I forget very easily, and my memory is horrible, except when it comes to learning things. So that's the only place where my memory shines really well. But yeah, so I was faced with the same issue a couple of years back. So Priya, back to your question, and what I essentially did was. This is not a plug for Kubernetes or KubeSlice, but what I essentially did was there are fantastic environments integrated within the Kubernetes documentation or the Kubernetes website, really, wherein you can try out Kubernetes as a project. Like you can go through the basics. We're trying to do a similar integration with KubeSlice so that you can try it out, but for Kubernetes specifically, there is integration within the website in itself to do basic tasks and figure it out. Um, Again, if that's not enough, and it will definitely not be enough, because as you uh, sort of upskill yourself and you go up the levels, you will obviously find that very less for the experience that you're trying to gain. So what I'd recommend is there are several platforms. I used to recommend Katacoda earlier, but it's now demised. So there is Killer Coda, and there's stuff like that wherein stellar content creators like Kunal and Sayam and others as well actually put out their Kubernetes environments for you to play around with. So you can actually access those environments for a particular period of time, tinker with clusters, fire commands, bring up applications, do things that you would normally do in an environment, and it's not restricted to XYZ commands, just that those commands. So that's what helped me. Katacoda was a major factor. Of course, installing it, there's nothing like installing it and playing with it on your own machine, to be really honest. Like that's I did not have that you know machine earlier on. My It was a gaming laptop, and honestly speaking, I do not even know why I purchased it, because it kept crashing every time I tried to install a Kubernetes cluster on it. So now I'm never going to buy a gaming laptop, and I know I don't even play games, so I don't know why I bought it. But um, installing it basically just helped me understand. And I also played a lot with the different distributions, and did not limit myself to just the vanilla one that is there and available for download. So I played around with the K3s, the K0s distribution as well. They are significantly lightweight if you have a more bulky, if you're more scared of bulky distributions. So, and like Leon said here, and not just in Oracle Cloud, I think all cloud providers have free creds. So that's another way. Yeah. So yeah, that's my 2 cents. Of course, people will
Thank
have
you.
different opinions on that. Yeah. Ooh, William, that's very very interesting. K3s on Raspberry 5 for home automation. It definitely would have run on my gaming laptop mostly. K8s crashed it 2-3 times, and I was like, I'm not going to buy another laptop ever
Yeah.
in my life that is related to gaming.
And added to that, I think you can also do kind clusters inside your own laptop
Yep.
for a smaller setup. So that'll be good. Right?
Yeah. So yeah, so I think did that answer your question though, Supriya?
Perfect. Thank you.
Yeah.
Yeah. All right. So I think we'll get on to the agenda for today. Prasad, why don't you go ahead?
All right. Once again, thank you guys. Thanks you for joining. And as we all recognized, now I think Divya will recognize us. We know Divya, but Divya, I am Prasad. uh, the celebrity who is very good. I think I appreciate what Divya is doing in the community from Kubernetes standpoint. Fun aside, right? She is very upfront in promoting Kubernetes, and this is the de facto standard for the container orchestration, right? And it is really, really powerful in many ways. So let me just take you through today. I think some of you have, Leon has written a blog, on KubeSlice, and as well as, Divya has done lots of different areas, right, on that one. So I will start presenting my entire screen for now, and then I will share with you guys different sets of things, right, for KubeSlice, right? So KubeSlice, what is it? Just to give you a brief introduction from a landscape standpoint, where it fits, right? There are lots of tools out there in the Kubernetes ecosystem, right? API gateways, lifecycle management, Rancher, and others, and service meshes and container networking. We are kind of at the bottom of the so that any of the above tools can also be used in the Kubernetes ecosystem on top of KubeSlice, right? So now what it solves is securely connecting applications across multi-cluster or inside a single cluster, and then have you observability and multi-tenancy. Right? I think Leon described in the video, tenancy is a set of teams or different customers or different kind of isolation which you need to have. And then when you get into multi-cluster scenarios, there is a whole slew of automation which needs to happen. And then that is all entirely handled automatically with the software-defined networks. And then we create an overlay network to create that. Right? So let me just take a quick I just created one slide just before starting this thing. So our construct is I think some of you have asked me a question, what is a slice? I think Kunal Verma asked me a question. I think there are different questions which I saw on asking about, okay, what is this slice? Slice is, if you look at it, is a virtual cluster across multiple physical clusters. So how does it, objects are defined? There is a controller which is actually managing multiple clusters, right? There is two levels of tenancy which we have described. You can have a project which is essentially dedicated to a specific enterprise, and then you have multiple projects. Or if you have an enterprise and you have multiple teams, you can have the project and then different clusters. These clusters, which I kind of put it across, are clusters which can be in multiple different clouds or in multiple different regions. And then what you do is you do a slice across multiple clusters so that the clusters will become like a physical virtual cluster across these multiple clusters. And then you don't have to, the combination can be any number, right? You can have 2 clusters in a slice, or 3 clusters in a slice, or 4 clusters in a slice, or 5 clusters in a slice, or just one cluster in a slice in one cluster. So these are kind of contained as an isolation principles inside the clusters. So what I'm going to do today is I'm going to show you what is there in the controller YAML. Sorry, what is the advantage of a slice, right? So the question is, in a typical Kubernetes environment, right? It's a one flat network or one flat, construct. So if you have multiple teams, you want to have a fine-grained access to your resources, which are designated to you as a team. Let's say there are multiple teams who are working in a cluster. Cluster can be a large thing, right? It could be like thousands of, hundreds of nodes and thousands of pods, right? Now, if you have a team trying to do something and then destroy somebody else's, it'll be an impactful thing from a production standpoint. You want to have certain guardrails. You want to be dedicated to you, right? Say, for instance, I'll give you an example. Somebody who is doing, let's say, AI-based model who needs a GPU-based node, right? So you want to dedicate that to a specific team, not to give it to everybody to schedule a pod on that, right? So how do you construct that? There are different ways of doing it. One easier way is the slice, so that you can dedicate that slice and an abstract that namespaces into this and then define that, right? So that way you get isolation, the right isolation. You get the right kind of RBACs, who is accessible, who is not accessible, and then you have all the privileges which you want to go across multi-cluster. All those things are given to you, right? So those are the benefits of slice, right? There are lots and lots from a security standpoint. You can also construct, yes, Sandeep, slice can span multiple clusters, right? And multiple clouds. not necessarily a cluster is, be it in GCP or be it in Azure, or be it in AWS and all that stuff, right? So that is the thing. Thank you, Leon, for answering. So now let's dig deeper in what we are going to show, right? What is the controller? How do you install a controller? How do you install a project? How do you install? How do you register clusters? How do you create slices? And then how do you deploy applications? So there are, if you look at our public repo, there are different examples out there. But all of these examples are kind of dummied down, and then we just do kind of as such. Everything is constructed for you. But what goes inside it, it is important for you to understand, right? So that's the reason why when you want to contribute, you will be very helpful to understand what exactly is happening inside the cluster, right? Or this thing. So that's the reason why I thought I would just spend time educating. So I have examples. I think Divya is going to store all these things in the thing. But let me give you, command line, and as well as you guys can see this screen, right? Yeah.
Prasad, I think it'll help if you just enlarge the screen. I'm not sure. Or let me try pinning it. Not sure if that'll help. Because just a second. If you can pin this, yeah, I'm not sure why it's coming because the um screen is small. But yeah, if it's visible to everyone else, it's okay. But
Yeah,
either if yeah,
it's visible. I mean, I think maybe you need to just click on that piece. It will enlarge.
no, it's already pinned. So
Mhm.
yeah, so the pinning is already done. But
Try going full screen.
All right. Is it the black background the problem, or is it?
I think this is good. I mean, we can make it out. Maybe it's the full screen. If you do it full screen, it's visible.
Uh, Thank you. So right now, in this demonstration, I have 3 clusters. You can see here, cluster number 1 is in AWS. This one is in AWS. And cluster number 2 is in GKE. And cluster number 3 is in, Azure in this case, right? I'm just going to give you, so what I did is I put the controller in AWS, and then I'm going to connect or create slices on top of 2, which is GKE and as well as AKS. So for this demonstration, I have a bunch of aliases which I use. For rather than typing all those things, there are a bunch of aliases. So don't worry when I say some commands. It is bunch of aliases. I can describe those aliases. It's much easier to do rather than just typing kubectl this, kubectl that, and all that stuff. So when I say k, it is pretty much kubectl command, right? So k is the command for that, right? And then right now, what I am doing is I'm going to say controller YAML file, right? So what it does is, pardon me, I don't want to show this, but anyway, controller YAML file will, let's take that slide. Controller YAML file is saying that here, you KubeSlice, you're installing it in controller with certain log levels, and then RBAC is prefixes for RBAC. Any kind of prefixes for role-based access will have KubeSlice / -RBAC, right? Any project namespace prefix, like if you have multiple projects, right? The prefix for that is KubeSlice, and then and describe it. For the namespaces, we create a namespace inside the cluster, inside the controller cluster, to put all the objects for the slices inside it. And the endpoint is the controller control plane endpoint. What is a control plane? If you look at Kubernetes cluster, Kubernetes, let's say in a let's say in an EKS, you just say kube cluster information. Okay. What did I type? Uh, so typing, that's a problem. So cluster information is this is where when you do an EKS, it's a managed cluster. Managed cluster means it has its own control plane for Kubernetes, which is essentially the scheduler, the controllers, the API servers. All of those things are managed by AWS. And then they give you all the EC2 instances for you to create your worker clusters. So this is your endpoint to talk to your API server, right? When you say K cluster info, it'll give you that endpoint. That is the endpoint you want to talk to in order to create a class, controller. That is the endpoint we give inside that. And then where you want to pull the repos, right? Where the images are stored, right? For the container images. So those container images repository, and then correspondingly, it's always in Docker Hub. And then you correspondingly pull the username and passwords as to what it is, right? So that means in KubeSlice, the controller is the central, like the Kubernetes has a control plane and a data plane, which is this thing. KubeSlice also has a controller, which is a control plane for all the managing clusters. You can manage tens and tens of clusters, be it in different clouds, be it in the same cluster, in a single cloud across multi-region, or in the same region, right? So since you are able to manage it, you want to know a central entity which has all the information of all these clusters. So that's what the controller's job is, right? So once you create the controller, then you have to create a project saying that, hey, I am a customer A enterprise, and then I want to have manage 5 clusters or 6 clusters, but I want to make sure they are grouped in certain entity so that you have the roles associated with it, what privileges you can have. So in this project YAML file, you're describing a project. I named that project as demo, and then I'm going to create it in the KubeSlice controller namespace. And then I can create a namespace, a service accounts called Prasad, Divya, Avinash, any kind of a thing, so that the secrets for them are created for you automatically. So if you take that, right, and then you apply that to KubeSlice, so it'll, like for instance, it'll create this KubeSlice demo, right? So KubeSlice demo will have, so Kubernetes gives you something called CRDs. CRD is custom resource. You can customize Kubernetes. So what we have done in KubeSlice is we have customized some certain set of objects, right? So get CRD and then pipe it to grab KubeSlice, right? You can see what are all the CRDs we installed inside this cluster. This cluster, in the controller cluster, we have a CRD called controller CRD, cluster CRD. There is a project CRD, and then service exporting configuration, slice config, and all that stuff. I'll describe that a little later, right? So there is a project CRD. So that means that these are the specialized configurations we have put inside the Kubernetes, vanilla Kubernetes cluster. For all of these CRDs, there is a controller which is looking for, if somebody is creating an object, what do I need to do? If somebody deleting an object, what do I need to do? All of those control machines are put into the controller. That is what it keeps looking for, all these things. So when you do kget pods -n, KubeSlice controller, right? This tells you that there is a controller manager, right? Which is what got created. And that controller manager is now monitoring all the events on the CRDs which you have created. So that is what the constructs of how you use Kubernetes, right? So ignore the UI and UI proxy and other. We have a rich UI which you can use it, but it is not part of open source. So I'm not going to spend time on it for now. But yeah, I can show you some other time as to how UI is useful and all that stuff, right? So now, when you looked at this slide, right? We said that we want to create a project called demo, and here you said that anytime a project prefixes should be KubeSlice. So that means you should have KNS. If you look at the namespace, you should have a namespace called KubeSlice, which is the prefix, and the project name demo. Right? So now that is the namespace it automatically creates. So now I am already inside it, right? Kget, clusters. So it will tell you that this project has two clusters, right? Cluster worker 1 and worker 2, which I will tell you how I registered it, right? And then this project also has, if I do kget slice config, our celebrity Divya has a slice on her own. So I created a Divya slice for her, saying that now what is the description of the Divya slice, right? K describe slice config. So it tells you, okay, a Divya slice is created, and it is on 2 clusters, right? It has a maximum of 5 clusters, what you want, and it has an application namespace called iperf, and then it is on both of them, and then it has QoS profiles associated with it. These are traffic shaping stuff. We will go through it later. And then across multi-cluster, you need to connect through OpenVPN, and it has a subnet, because we create an overlay network. Leon, you described that overlay network, right? That overlay network is described in that subnet. So that is all what you need to do, and then everything else is taken care by the KubeSlice, right? So that's a description what you can do in this. So every time when you go into a cluster, not for just KubeSlice, right? For you educating yourself, most important for you to do is, what are the CRDs there? What are all the things which you have? So what you need to do is, can you go like I did, right? You can do kget CRDs, and then correspondingly, if I don't do the grep and then do it, I got lots of CRDs in there, right? There is a cert manager CRD. There is a Amazon has its own CRDs. Different sets of things. When if you change the context to GKE and then say get CRD, you will have hundreds of them, right? There are, Google has its own CRDs. What it has, the BGP peering so Calico CNI has its own CRDs, right? IPAM has its own CRDs. We have our own set of CRDs. So that is one way of learning what CRDs are doing, and then you can describe them, and then kind of figure out what are all the objects you can discover and investigate, right? So that is one way of learning what KubeSlice does. So what we can do is in the worker cluster, if you do KubeSlice, it tells you that it has a service export import, slice gateway, and slice resource quotas, right? Those are all the CRDs which we have installed from KubeSlice, apart from others are installed by others, but we have installed some of them, right? So that is the kind of thing what you need to do when you do a register cluster. Register cluster is done in 2 steps. Step number 1, say for instance, you have a controller, you're sitting in AWS, and you want to manage some clusters. Randomly, you don't want some cluster to come and then say, hey, I am ready, manage me. That is how attackers attack, right? You don't want to be doing that. You want to actually authenticate who is coming to you, right? So that you know exactly who you are managing it, but not randomly managing other clusters, right? So that's the reason why we have a 2-step process. Step number 1 is you create an object inside your cluster saying that I am going to register this cluster, and that cluster happens to be, in this case, is GKE. I'm going to expand the slide so that you can see it better. So I'm going to create an object called cluster, which is a kind CRD. It is in GKE, but it has an ETH0. Don't worry about the network interface. I'll describe it some other time. And then that endpoint is so-and-so. And then GCP is so-and-so. It's in GCP provider, whether it is in some specific region, you describe it. So what does the controller do is, now that you created an object called create a cluster, it creates a secrets for that object. So then you take those secrets and put it inside your where you want to register into that controller. This is a namespace. See, for instance, you're in a project called KubeSlice demo, right? We don't expose even that. We expose it in a base 64 encoded content. So that when you see visibly, you won't know what exactly it is, right? So it is a base 64 content. And then, sorry, what happened? So then you also have the certificate root authority and the token generated by the first step. Use those things and then tell you what is the endpoint for your control plane, whatever is the control plane you're going to do that. And then what is the interface on that particular. So important to note, clouds, public clouds have VMs, EC2 and other things. So those VMs have a specific way of interfacing the node. When you go to data center, or when you go to Tanzus of the world or some other set of the world, they also have different way of encoding that interface. So currently we exposed it, but we will remove that so that we can do an auto discovery of all these things. But in the case that is the reason why you want to know where that network interface is, because at the end of the day, we do a lot of things with respect to overlay network, right? So you want to know that. So this 2-step process, right, will help you register a cluster into your controller. So that's the reason. That's when you should see. Where am I? I am in. I have a alias called C1, C2, C3, cluster 1, cluster 2, cluster 3. Is like a way to switch clusters, right? So then you say kget clusters in namespace KubeSlice demo, right? That describes that there are 2 clusters registered onto it. If you look at describe cluster worker 1 minus n KubeSlice demo, right? It tell you that is the RBAC secret, right? and the geolocation of that cluster, what's the dashboard enabled on that cluster, and all that is described inside that. So here, this is the secret, right, which we have used to go to worker one, right? So because it has created one, and then you use that to put it in your text file, and then you upload it. That's get registered, right? So that tells you about the now on the register cluster. Now you are wanting to create a slice, right? Slice is a way of creating a virtual cluster across multiple clusters. What you are saying is, I am going to take certain namespaces and group them together and then form a virtual cluster, right? So that is what this YAML is saying, right? YAML is saying, define a slice config. The slice name is meetup demo. Overlay network, we can take that offline. And then one other topic about networking, what it does from a pod networking and all, life of a packet, I can describe you in the next on some other office hours, but I will park that networking part today, right? So it describes that this is an application slice type of application, right? The connection between the two clusters should be OpenVPN, and then this so happens that it is only on these two clusters. If I have 3 other clusters, don't touch them, but only these 2 clusters, only touch them, right? The queue type is hierarchical token bucket. From a traffic shaping standpoint, we have a hierarchical token bucket. So if you guys are Linux proficient, Linux has a whole description about how token buckets are used for the traffic shaping and other stuff. You can read about it, right? Any traffic leaving out of this cluster, put the priority so that you can have priority on all the traffic. And then you have a ceiling on the bandwidth. You don't want to burst too much. You want to reduce the thing. So those are all the parameters which are described inside a slice. And then you can define certain namespaces across these clusters, right? Multi-cluster SIG has defined something called same nameness, right? You can have a namespace across multiple clusters the same, so that you can have certain simple principles and all that stuff. So likewise, you can define a namespace, and then you can say, hey, these namespaces, I want to have an isolation, because the slice is a definition of an isolation. You can say isolation is true enabled. Right? So that is the definition of the slice, right? So I'll do is, for in this, given that we have only 10 minutes, right? I have a bunch of files. So I created a meetup demo slice, right? It's the same thing as I showed you in the PowerPoint, right? And I added a namespace called Team A, right? I can add more than one namespace, right? Team B and Team C also, right? And then, say to the controller, hey, Mr. Controller, I want to create a slice on all these 2 clusters. Go do it for me, right? So it automatically creates a virtual cluster across those 2 clusters, right? So let me do that real time with you guys, right? So we are in cluster 1, right? Um, let me say KNS. I am in KubeSlice demo namespace. If I do kget clusters, I know that there are 2 clusters. If I get kget slice config, there is only one slice, right? Divya slice, which I showed you before, but the meetup slice is not there yet, right? So now what I'm going to do is k apply -f meetup demo slice, right? And in the project KubeSlice demo, right? So you had seen the thing. Now I'm creating yet another virtual cluster from the same physical clusters, right? So I do that, boom, right? Get um, slice config. Now I have 8 seconds ago, I have created this meetup demo slice, right? Now, if you go to cluster 2, which is GKE, right? KNS, right? We create a KubeSlice system, right? So previously, as I decide, get CRD grep KubeSlice, right? You know that, oh, there is a CRD called KubeSlice. There is a CRD called slice. So then you can say get slice, right? Minus n cube. So there we go. Now I went and created that in the controller cluster, did nothing on the virtual physical clusters, right? But automatically it is taken care. So I have another slice which has, if you look at it, it has KubeSlice demo, right? K describe uh, slice uh, meetup demo, right? It has so failed to sync QoS profile, but that's okay, right? But at the end of the day, it has the same clusters created, and then application files are created, and a slice is created across multiple the clusters, right? Okay. When you look at kget pods, right, automatically it has created a router which needs to go across multi-cluster, and then it has also created a gateway, which is what is going to get created to connect to multiple clusters, right? So if you look at C3, uh, uh, right, okay, get pods, that's also there, right? So that is the kind of constructs which you can think of when you want to do, KubeSlice. I know I took a lot of time. It is a little dense involved. So hope you understood the constructs behind the YAML. You can play with these YAMLs. They are out there in the public, repos. Right? Any questions? I'm more than happy to answer.
So, Sandeep, actually, when you were doing the whole thing, he had asked a couple of them. I answered one of it, but just for the sake of clarity, he wanted to know where the YAML file was located when you were creating this whole thing. So, where is it exactly located? What is the directory location? Is what he had asked.
Um, Sorry, the YAML file is sitting in my local directory, right? So, and I have a kubeconfig to talk to different clusters. So I have a configuration parameters. So YAML files can be anywhere in your local directory, right? It doesn't have to be in any specific location. Typically, you're better off organizing, your YAMLs such a way that you don't miss them, right? So let's say I'll share with you my organization structure, right? um, I don't know whether you guys can see this, or is this better or no?
It's small, but it's Okay, I guess.
Let me do something else, right? I think uh, is this better now?
Yeah, that seems
Right?
better.
So I generally try to do something called city clusters. I have a bunch of my own YAML files for what clusters which I have, and then I have a values directory. But it doesn't matter because this is my local machine. So the way it matters is that under tilde slash dot cube, there is a config file which tells you what are all the certificates you need to use in order to get to different clusters in different clouds, right? This, since you have to have that config file, to you create those config files once the cluster is created, and then you store it, and now all your kubectl commands will work, right? So that then your local machine will act as a repo to go. So typically in the production, all of these things are set in a Git repo, and the pipelines will actually run those things, right, rather than putting into your local machine, because there is no version control in your local machine, right? So that's the reason why you don't put those things in your local machine. But for the demonstration, it is easier for me to show. That's the reason why I have it here.
Hey Prasad, one question I have. So to summarize, maybe this is my first class, so maybe I couldn't follow everything, but whatever I understood, maybe I'll just summarize around the slice part. So is it slice is kind of a used leverage to deploy files onto clusters? Am I correct in understanding?
Slice is a way to shard clusters and then create virtual clusters of a single physical clusters, right? So if you have an organization and you have 3 or 4 teams, right? Divya describes it differently. If
Yeah,
you are multi dwelling tower,
yeah,
right? And that tower is a cluster, and then each tenant who taking a portion of that tower is a slice, right,
right.
Divya?
Yeah, so essentially, Spira, what a slice does is, um, you have one application that you need to run across, uh, say, several clusters, or maybe you don't even need that. Um, you need several applications running on the same set of clusters, but you need them isolated from each other. How we used to have VMs back in the day, we can't say that because we still have VMs. How we have VMs separated by hypervisor is essentially the logic behind this, but here we achieve it via a networking construct of an overlay, wherein the same overlay will be for all
Like,
for everything within a slice, and that slice is basically the overlay. That's the abstract we use. That's overlay is essentially what provides the isolation, just like when you go for a tower or a building or a whatever, you have physical isolation, right? So obviously in a containerized world you can't have a physical isolation. So yeah, so that's basically what it does. It's just a networking construct. And It's not just because there's obviously a lot of hard work, but it's a networking construct that basically provides isolation, and you can have multiple such constructs across the same set of clusters. That so that applications don't bump into each other. You can have different people use different with different privileges use the same set of applications. Dependent upon your use case, you can have different things, like you can have different teams access the same set of applications with different privileges. So there are multiple use cases, but essentially it is just a case for isolating applications across clusters, but also allowing for clusters to spread across, sorry, allowing for applications to spread across clusters. Did I get that right?
Yeah,
Perfect. Perfect.
Yeah.
Perfect. That
yeah,
sums it up. Thank you.
Yeah.
yeah. So Sandeep, I see your question. How will Kubernetes know where to find my config files? Kubernetes does not have config files. Kubernetes, when the config file comes in, it creates objects, and all those objects are stored in a centralized place called etcd, right? Which is where everything is stored. So the the YAML files are translated into objects, and objects are the ones which are getting stored inside Kubernetes. Did I answer that question, Sandeep? Yeah.
All right.
Arpit,
Oh yeah, I'm
sure,
so
go ahead.
sorry. Yeah.
We
Arpit,
have time. Go ahead.
yeah, I'm so sorry. Who was saying something? I'm sorry. I just wanted to wrap it up because it's 9:30 right now, and I realize that a lot of us are in the time zone where we have to go back to work, and a lot of us have to go back to sleep. So just just staying conscious of time here.
Yeah. Thank you very much. Thank you, Divya, for facilitating this.
Yeah.
Uh, yeah.
I promise to remember my password the next time on. So and it will not take so much time for me to log on.
No,
Apologies to
no, but
everyone who logged in first.
let,
Yeah.
let me just do a pun here. You promised to remember all the people who joined the call, right?
Yeah, that is if I promise to remember my password. So I will have to do that as well.
The new celebrity here, guys, Mumbai.
You'll give me too much credit, but thanks. I think Avinash had one last question. KubeSlice creating a group of clusters via slice. Is there any chance KubeSlice can help us with providing HA cluster property? I think
Absolutely.
that's essentially what it does. With multiple clusters, you get HA. Um, High availability is essentially facilitated with multiple clusters, right? So if you have um, one single application across different physical clusters or even different virtual clusters or across different clouds, you are essentially facilitating high availability. So when you are creating a slice, it will be across clusters. It will not be in just one cluster. You can have that, but you will technically go for a high availability mechanism. You will not have a slice across the same cluster because then it doesn't make sense, right? You want high availability in this day and age. Otherwise, if an application goes down, it just it's just not acceptable any longer. So yeah, did I answer your question?
Yeah,
Well,
yeah,
yeah, go
yeah.
ahead.
Yeah. All right, guys. I think I'll take those questions back into the Slack channel. Would love
Yeah,
to answer all those things in the Slack. All right.
yeah. So so we're there on CubeSlice on the Kubernetes Slack channel. For those who do not know what is the Kubernetes Slack channel, I'll just post that here. Um, and yeah, I've also created a dedicated thread for that. You all should be able to view that thread once you log in. Oh yeah. Uh, I think
Thank
I'll wrap
you.
it up now if that's all good with everyone. Please post your questions on there since we're running out of time right now. And thank you everyone for joining in. Have a great weekend ahead. Bye bye.
Bye-bye.
Right.
Bye.